Hello, good evening, students. Nice to see you people back. We were doing work, energy, and power, and in the previous class, we had done potential energy, right? We had done the different forms of potential energy. Today, we will go into kinetic energy. I welcome Anushka. She's always the first one to join. Then Pratika Maheshwari. Both of you answer also a lot. I welcome you both. Okay, we start with 2.12, that is kinetic energy. Okay, now if I have a ball and I throw it towards the stumps, okay, what happens to the stumps? If it hits the stumps get shattered. Okay, if my throw is very powerful, then sometimes the stumps go rolling also. Okay, so how does this happen? Okay, it shows that the ball has applied a force, right? It shows that the ball applied a force on the stumps. Okay, that is why it could displace the stumps. The ball has displaced the stumps. Okay, which means that the ball has done work on the stumps. It has applied a force on the stumps. It has displaced the stumps, which means the ball has done work. Okay, if the ball can do work, it means that this ball has energy in it. Okay, anything which has energy in it only can do work. So if the ball has been able to do work on the stumps, okay, if it has been able to apply a force, if it has been able to displace it, then it means that it has energy. From where does this energy come? Okay, this energy comes, the ball has this energy by virtue of its state of motion. Okay, so this kind of energy is known as kinetic energy. We represent it with a capital K. Okay, so the energy possessed by a body, some more people join in, I don't know who is it. Okay, uh, what problem do you have? Okay, so the energy which a body possesses by virtue of its motion is known as kinetic energy. When we had studied potential energy, we had studied that the energy possessed by a body by virtue of its position or configuration is potential energy. And today we study that the energy possessed by a body by virtue of its state of motion is known as kinetic energy. That we represented by U, this we represent by a K. Right? Everybody understood? The ones who have joined late, I hope all of you have understood. Okay? We move on. We move on to the expression for kinetic energy. I'll erase all this. Okay, now we go to expression of kinetic energy. How do we find a kinetic energy? We have understood that it is the energy possessed by a body by virtue of its motion. So how do we derive it? How do we arrive at its expression? Okay, so for this what we do is we consider a keeper. Now when I throw the balls towards the stumps, you must have seen there's a keeper who collects the ball, right? Who stands behind the stumps. Our Indian captain MS Dhoni himself was a wicket keeper. Okay, so a wicket keeper is standing and I throw, trying to run out one of the batsmen. I throw the ball towards the stumps. Now the wicket keeper, he collects the ball. He brings the ball to a stop. The ball stops. How does it stop? It can only stop when the wicket keeper applies a force. Okay, which applies a force. He does work, okay, which is equal to the work which the ball was doing. Okay, when he neutralizes the energy, which means he also spends an equal amount of energy, right? So let's go there. We say ki now how much work he does, let mass of the object or the ball be m, okay, and its velocity, let its velocity be v, right? Uh, the opposing force. Now, this force is being applied by the person who stops the object, or the wicket keeper in this case. Okay, so now we have considered a object. In our case, we have considered the ball. The mass of the ball is m. It is moving with a velocity of v. Okay, we are talking about kinetic energy, energy by virtue of its state of motion. So we say it's moving with a uniform velocity v. Okay, now we say the wicket keeper, to stop it, he applies a force. He'll apply the force in the opposite direction. The ball is coming from this side. He applies a force in this direction, opposing force F. Okay, and once he applies the force, then the ball will take some time to stop. Okay, so the displacement which it does before it comes to a stop, we say let it be S. Okay, now once it has stopped, then the final velocity of object will be equal to 0. Okay, now whatever we have understood, that whatever work the wicket keeper does, okay, the kinetic energy will be equal to that much. Okay, work done by the opposing force. So whatever work the opposing force does, the kinetic energy which was possessed by the ball should be equal to that, right? So we know that work done is equal to force into displacement, right? This is our first equation. Got it? Everybody understood till here? The work done is equal to force into displacement. Now we have understood that the ball was coming towards the stumps. Okay, if it strikes the stumps, it topples the stumps get displaced. जब गेंद विकेट से टकराती है तो विकेट डिस्प्लेस होता है अपनी जगह से. इससे हमें पता चलता है कि बॉल ने विकेट के ऊपर काम किया, मतलब बॉल के पास एनर्जी थी. ये एनर्जी कहां से आई? ये एनर्जी उसके मोशन के कारण आए. अनुष्का, yeah, you have written the you have written the expression. Okay, and she says retarding force, correct? Retarding force into displacement, very nice. This is the retarding force F into displacement, perfect, Anushka. Okay, and Shingarika says work only. Work only what, Shingarika? It is equal to the work done by the retarding force, which means the retarding force into the displacement before it comes to a stop, right? So now we move forward. We know that force is equal to mass into acceleration. Okay, so now we write that. I go up back now. From Newton's second law, retarding force F is equal to mass into acceleration. Okay, we had taken the mass of the object to be m. Okay, so mass into acceleration becomes the retarding force. Now let us calculate S. Okay, for calculating S, we use which equation? We use which equation? We use the third equation of motion. Okay, now v square okay, is the final velocity, and we know that the final velocity has become 0. Okay, so it becomes 0, and we have said that the initial velocity was v, so this becomes v square. Okay, the it is a retarding force, so the acceleration is negative, so it becomes -2, and displacement stays there. So now we cross multiply, 2as comes this side, okay, which means s is equal to v square by 2a. Okay, this was our second, and this is our third, right? So we put values from 2 and 3 in equation 1. So what does it become? It becomes k is equal to f, we have put mass into acceleration, s we have found out, okay, v square by 2a. Okay, so a cancels, and what am I left with? I'm left with half mv square. Okay, so kinetic energy is equal to half mv square is the mathematical expression that we have obtained. Everybody understood, Anushka? V square is going to u square. Very nice. I had asked which equation are we going to use, and Anushka Sahai had replied the third equation. Okay, v square is equal to u square plus 2as. So we use the third equation, and we find out s in terms of the final velocity 0, the initial velocity v square, okay, and the retardation minus a, which comes out to be v square by 2a. Then we had known that the kinetic energy will be equal to the work done by the retarding force. The work done by the retarding force was F into S. We had found out from Newton's second law that force will be equal to mass into acceleration. We put that, we put in the value of S, A cancels, and we arrive at kinetic energy is equal to half mv square. Done, Anushka says, understood. Thumbs up. Kratika says, yes sir, understood. Okay, and Shingarika is missing now. Okay, now let us consider a few more things. Okay, so now that we have arrived, let's see. Now suppose these fielders, the two fielders, okay, now they start bowling practice. They have placed one stump and they are coming and bowling. Now Mumbai Indian bowlers are practicing. Okay, so first comes Malinga, okay, and Malinga Salinga, he throws the ball, okay, and the wicket flies away. It flies away to quite a good distance. Next comes Harbhajan Singh, okay, Harbhajan Singh bowls, and the wicket just drops down. It doesn't fly away. Okay, now mass of the ball is the same for both, right? They are using the same ball. Malinga also uses the same ball, and Harbhajan also uses the same ball. Then why is it that when Malinga bowled, then the wicket flew away to quite a distance? On the other hand, when Harbhajan bowled, it just went a little distance. Okay, the difference is in velocity. Okay, the difference is in velocity. The speed with which Malinga bowls is much greater. You know that Malinga is a fast bowler. On the other hand, Harbhajan is an off spinner. Okay, so we have seen in our expression also, if the velocity is greater, the kinetic energy will be greater. Got it? If the velocity is greater, the kinetic energy will be greater. It is proportional to the square of velocity. Now we change the situation. Everybody understood this? Anushka says velocity is changed. Yeah, very nice. Smart girl. Velocity is different. Malinga's velocity is greater. So if Malinga's bowls with a greater speed, his kinetic energy with which the ball will possess by virtue of its motion will be greater. So the ball which Malinga throws has greater kinetic energy as compared to the ball which Harbhajan throws. Right? Next, what we do now? Only Malinga is bowling. Okay, only Malinga is practicing. First, he practices with a cricket ball. And he comes and bowls, and the stump flies away to great distance. Okay, now he puts back the stump, goes back to his running mark, Now he comes with a tennis ball. Okay, and now he bowls. Now when he bowls with the same speed, when the tennis ball strikes the wicket, it just moves a little. It doesn't go flying away like it had gone in the first case. Now what is the difference? Okay, now what is the difference? Kratika says, excellent, Shingarika. Mass of the ball has changed. Shingarika is the first one this time. She's woken up from a sleep. Okay, so this time the mass of the ball is, Anushka also comes in, mass is changed. Very nice. Which one has a heavier mass? The cricket ball. The leather ball is much heavier as compared to the tennis ball. The cricket ball has greater mass as compared to the tennis ball. So greater the mass, greater is the kinetic energy. Hence, when he bowls with the cricket ball, because its mass was greater, so the kinetic energy it possessed was greater. So the work done by it was greater. The stump goes rolling away, cartwheeling away. Right? Okay. The first question is, how fast should a man weighing, okay, 600 newtons, how fast should a man weighing 600 newton run? That is kinetic energy. Kinetic energy is equal to 750 joules. Okay. They are asking how fast should he run, which means they are asking us V is equal to how much. Okay. Now we know that we don't have the, now in this question what kids do generally, what wrong they do, kids think that this is the mass. Okay, and there they go wrong. They solve it taking this as the mass and the answer comes out to be wrong. Okay, here this is the weight. Okay, and we know that weight is equal to mass into gravity. Okay, which means 600 newtons is equal to m into 10 meter per second square. So m comes out to be 600 by 10, which means it is equal to 60 kg. Right? Now we apply using kinetic energy is equal to half mv square. Okay, kinetic energy is given to be 750 joules. So we put 750 joules over here, half into 60 kgs into v square. Okay, this 2 goes up into 2 and this goes down by 60. Okay, okay, I was taking the 0 after cancelling it. Okay, so this cancels, this 2 3s are 6 and this is a 25. So v square comes out to be 25, which implies that my v is equal to 5 meter per second. Right? Now, Kartika gives 5 meter per second, Shingarika gives 5, Anushka gives 6. I am late this time. I got confused with the 0 over there. I took it even after cancelling it. Okay, we take one more example. So these are simple questions, all of you can do it, no issue in these. We take one more example. Okay, and this time we take, this is an interesting one. How is the kinetic energy affected? Okay, they are telling what happens to the kinetic energy if mass is doubled. Mass is doubled is A, and then its velocity is reduced. B, velocity is reduced to 1/3. Okay, of the initial velocity. Okay, now we say that let the kinetic energy, we know we're using K is equal to half mv square. Okay, and we say that the new mass m dash is equal to 2m. They say it is doubled, so it becomes 2m. So what does k dash become? K dash is equal to half m dash v square, okay, which means it becomes half into 2m into v square, right? So I pull out the 2 and I put half mv square. So this is my first equation, okay? So from 1, k dash is equal to twice k, right? So when the mass is doubled, we just saw the example also of Malinga using the cricket leather ball and the tennis ball. Okay, with the leather ball, his kinetic energy which the ball possessed was greater, and the tennis ball possessed less. So when the mass is double, the kinetic energy gets doubled. Okay, we go to the second one. When velocity is reduced to 1/3, okay, we say that v dash is equal to 1 by 3v. This is the second case. Okay, so k double dash is equal to half m v dash square. Okay, which means is equal to 1 by 2 m, okay, 1 by 3 v ka whole square, which means this becomes 1 by 2 into 1 by 9, okay, mv square. I take this on the other side, okay, I bring 1 by 9 in front into half mv square, which means this is equal to 1 by 9 k. Okay, so k dash becomes 1 by 9 times the initial velocity, right? It becomes 1 by 9 times the initial velocity. Easy, understood? Anushka, what does he say? Half into 1 by 9, correct. You use a good connection, Anushka. Before I have done, your answers are there on the screen. Shingarika also today is going good. 1 by 9 of the initial kinetic energy. So very easy, everybody understood? What I have to do is assume that the body has mass m and velocity v, and I write the expression for kinetic energy. I name it my first equation. Then I go to the cases. In the first case, the mass is doubled, so I replace m by 2m over there. I again change it in this form by bringing whatever else is there in front. So I bring in the 2 and I keep the expression of the initial kinetic energy over there. Then I replace it by k, which means k dash is equal to 2k. Similarly, when I go to v dash, I again do the same thing. I replace v by v dash, which is 1 by 3. I square, then it becomes v square by 9. I pull out the 9 and keep everything else in the initial form. So it becomes, I replace it by a k from the first equation, and it becomes 1 by 9k. Right? All are smart kids. Okay, Shingarika, Anushka. Kratika isn't answering today. Kratika, what happened? Gone to sleep? Understood? Yes, no. Anybody who didn't understand can tell me. Okay, I can explain it to you once again. One more numerical I take, and then we go to the expression. I mean the relationship between momentum and kinetic energy. Now this one. Okay. For the same kinetic energy. This pen is not working. There's one more such pen. Where did it go? For same kinetic energy, what should be the change in velocity? Okay, v dash is equal to question mark if mass is changed to, if mass is increased 4 times. Okay, if m dash is equal to 4m. Okay, we go the same way. We say let the initial mass be m and the velocity be v. Therefore, kinetic energy is equal to half m v square. Okay, this is our first expression, and then they say that the kinetic energy is same. Okay, the kinetic energy is same. For case 2, what does the kinetic energy become? K dash becomes half, okay, we do not know m dash, okay, and no, we know m dash is chalo let's write m dash v dash whole square, okay, which means this is equal to half into 4m, okay, into v dash ka whole square. So the kinetic energy should remain same, they say, okay. So from 1 and 2, 1 by 2 into 4m v dash whole square is equal to half mv square, okay. So what cancels? Okay, this 2 cancels, this 2 cancels, this m cancels, this m cancels, right? So what are we left with? We are left with v dash whole square is equal to v square by 4. Got it? So we take the square roots on both the sides, which means v dash is equal to v by square root of 4 is 2. So half, we should reduce the velocity to half the initial value. If we reduce the velocity to half the initial value, velocity is halved, says Kratika. Good, Kratika, you are back. Now Anushka has gone to sleep. No, there she is. Anushka also. See, she says that. No, what is this, Anushka? V square is equal to ke by 2m. This is the previous one. She's taken it back now. Okay. And Shingarika gives the right answer. Shingarika says, first she gives me awesome, and Anushka gives me a thumbs up, and Shingarika says velocity is halved. So wonderful, kids. Now we have done a few questions. We know this is the time, these are the types of questions which come, okay. They tell you that the mass is made 3 times, the velocity is halved, what will happen, okay, will the kinetic energy increase? I have given you the example of Malinga and Harbhajan. Remember that? If those pictures are in mind, okay, in the first case Malinga was throwing with a greater velocity, greater kinetic energy. Harbhajan threw with a lesser velocity, lesser kinetic energy. In the second case, remember the 2 balls, okay, the cricket ball and the tennis ball. When he throws the cricket ball, its mass is greater, so kinetic energy is greater. In the second case, the tennis ball, the mass is less, so kinetic energy is less. So keeping in mind, if you do this, solve the questions, you will not go wrong, okay. You can check your answer, confirm your answer, because when you start solving it, you will already have the answer in your head that it should come this much greater or lesser, right? Now we go to the relationship. Now we go to the relationship between kinetic energy and momentum. Okay, we have just found out that kinetic energy is equal to half mv square, right? And in class 9 we have studied, okay, we know in class 9 we have studied that momentum is equal to mass into velocity, right? So this is one, and this we exchange, okay. We find velocity in terms of momentum and mass, so it becomes p by m. This is our second expression, okay. So we putting value from 2 in equation 1. So what does it become? It becomes that, oops, I should have written k only over here, okay. So it becomes k is equal to half m, and then I put p by m ka whole square, okay. So this is equal to half m p square by m square, okay. M cancels, so what am I left with? I'm left with k is equal to half p square by m, okay, which implies that, this is my first expression, okay, uh, which is equal to p square by 2m. This is my first expression, and I will also go, let me put it once again so that I can encircle it, which implies that k is equal to p square by m. This is the first expression which we get. Okay. Now what we do, we cross multiply it. When I cross multiply it, it becomes p square. P square is equal to 2mk. Okay, which implies that p is equal to root 2mk. This is my second expression. So we'll have to remember these two expressions. Very nice. P is equal to under root 2mk. Singarika, wonderful. And Kratika had given us k is equal to p square by 2m. Anushka also gives us k is equal to p square by 2m. So you should memorize this. I hope you girls are working hard, you're practicing. So you should already have memorized this. If you haven't memorized, याद कर लो, न्यूमेरिकल्स करने पड़ेंगे इसको, तब ऐसे यूज करना पड़ेगा. ठीक है, डिराइव करने में थोड़ा सा समय लग जाएगा. अगर भूल जाओ, घबराना नहीं, बहुत इजीली डिराइव हो जाता है. आपको मोमेंटम भी मालूम है, आपको काइनेटिक एनर्जी भी मालूम है. काइनेटिक एनर्जी इज इक्वल टू हाफ एम वी स्क्वायर. मोमेंटम इज इक्वल टू मास इनटू वेलोसिटी. मोमेंटम वाले में से वेलोसिटी निकाल लीजिए p बाय m, उसको सब्स्टिट्यूट करिए एंड यू अराइव एट द एक्सप्रेशन k इज इक्वल टू p स्क्वायर बाय 2m. 2 कहाँ गया? 2 लिखा ही नहीं इसमें. ओके, k इज इक्वल टू p स्क्वायर बाय 2m और उसको क्रॉस मल्टीप्लाई करिए एंड यू गेट द रिलेशनशिप अगेन व्हिच इज p इज इक्वल टू रूट 2mk. राइट? सो we take two cases now. The two cases are given in your book. I'll erase it from the top. I'll leave the formulas down there. Okay, now case 1. A light body. A light body of mass m and a heavy body of mass capital M. What is common in them? A light body of mass m and a heavy body of mass capital M have same momentum. Okay, have same momentum. Okay, now they say they have the same momentum. So which one has greater kinetic energy? They have the same momentum. Which one has greater kinetic energy? Now which one will we use? This one or this one? Okay, we use this one because they are asking us kinetic energy. They are telling that the momentum is same. Which one has greater kinetic energy? So the P will be common. We'll get to know which one has greater kinetic energy. Okay. So we find the first of the lighter body. K of the lighter body is equal to p square by 2m and K of the heavier body is equal to p square by 2 capital M. Got it? So we take the ratios. KL by KM is equal to p square by 2m divided by p square by capital 2m, which means it becomes p square by 2m into 2 capital M by p square. P square cancels, 2 cancels. This is equal to capital M by M. We know that we had said over here that M is greater than M. Okay, which means that the kinetic energy of the lighter body, is greater than the kinetic energy of the heavier body. Easy? Understood? Kinetic energy of mass M is greater. No, beta, Shingarika, that's wrong. Kinetic energy of the greater mass is not greater. We just found out. Kinetic energy of the lighter mass is greater. Okay, it flips. Like p square by 2m है, p square by 2m है. Okay, तो जब मैं इसको डिवाइड करता हूँ, मैं उनका रेशियो निकाल रहा हूँ, तो p square by छोटा 2m divided by p square by बड़ा 2m. When I multiply, it flips. So this m goes up. This m goes up. So the ratio becomes capital M by the smaller m. Capital M छोटे m से बड़ा है. ठीक है? This mass is greater, which means kinetic energy of the lighter body is greater than the kinetic energy of the heavier body. Lighter is Kritika is the correct answer. Okay, Anushka says uh, M is greater than M, therefore kinetic energy of the first body or the lighter body is greater. Correct. Shingarika also understood. She says, okay, that's smart. I like such students who immediately say understood and then they accept that, okay, I had gone wrong, no issue. Okay, wonderful. That shows that you're learning, that you're open to learning. Such children grow to great heights. The ones who are open to learning, who says, okay, making mistake is normal. Okay, I'm human being. To err is human. But you should not repeat your mistakes. You should learn from your mistakes. Right? आज का वो भी दे दिया, प्रवचन भी दे दिया. Okay, we move forward now. We go to case 2. Everybody understood case 1? Everybody understood case 1? We do go case 2 now. Okay, case 2 will be the last thing we do for the day. I've got just 5 minutes more. So let me finish case 2 and that will be all for the day. We missed a class on Monday due to technical issues, right? So they have arranged a class, I suppose. Whenever they arrange it, most hopefully I think it's on Sunday. So Sunday will be back. Sunday will proceed further. Okay, we go to case 2. Now case 2 says that, okay, again we have a lighter body of mass M, okay, and a heavier body of mass capital M have what same? Last time they have the same kinetic energy. Okay, using P is equal to under root 2 mk. So don't worry. The expression is P is equal to under root 2 mk. Okay, so हम पहली वाली body, we say lighter body, we name it A, and a heavier body, we name it B. Okay, so this बन गया under root 2 m and the kinetic energy is the same. Okay, और दूसरी वाली का कितना बन गया PB. दोनों का रेशियो ले लेते हैं डायरेक्ट. Okay, दूसरी वाली का कितना बन गया under root 2 capital M K. Okay, so under root 2 cancels, K cancels. Okay, which means we are left with under root M by bada M. Okay, we know that this capital M is greater than the smaller m. The mass represented by capital M is greater than the mass represented by smaller m, which means that the potential energy, the momentum of heavier body is greater than momentum of lighter body. Got it? We compared the momentums. We know the formula for momentum is equal to under root 2 mk. It is given that their kinetic energies are same, but their masses are different. One has a lighter mass m, the other has a heavier mass capital M. So we put in the values. Okay, since the kinetic energies were same, so they cancel out. 2 also, under root 2 also cancel out, which means I'm left with square root small m by capital M. Okay, and we know that capital M is greater than small m, which means capital M is down over here, which means the momentum of the heavier body is greater than the momentum of the lighter body. I've got some heavier body has greater momentum, right? Everybody understood? So that finishes kinetic energy, the relation between kinetic energy and momentum, and we did a few numericals also. Next time when I come, we will do some more numericals and move forward. We will go to conservation of energy. Right? Thank you very much all of you. That's all in today's class. See you again.